Hello friends, it's your NOLA Mathman coming again for another fun math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to solve quadratic equations by the concept of completing the square. With no further ado, let's get into our lesson. So in this first group of problems, we're finding the value of c that makes the trinomial a perfect square. Now, in order to do that, you have a particular formula that represents the c term of a quadratic square. And that formula is b over 2 squared. So we will look at the first two terms. The second term is in the form of bx. Using that term, we will pull out b. b in this problem is 6 because you have 6 times x. So we write that value, we substitute it into the equation b over 2 squared. 6 over 2 squared, that will simplify to 3 squared, which is equal to 9. And so that will be our c value for number 1. So it's a pretty simple process. You memorize the formula b over 2 squared, you identify b, and you plug it in. Next problem, x squared minus 14x plus c. Again, we want to write our general formula, which is x squared plus bx plus b over 2 squared. And what it factors into once you make it a perfect square trinomial, the binomial square is x plus b over 2 squared. So you want to get in the habit of doing that because we're going to use that when we're solving. So in this problem, b is equal to negative 14. We substitute negative 14 into our equation, b over 2 squared. Negative 14 over 2 is negative 7. Negative 7 squared is 49. And so c in this problem is 49. All right, let's see, we'll do another one. Now this one here, we have x squared plus 5x plus c. Again, we want to be in the habit of writing the same formulas over and over. It gets you in the habit of memorizing the b over 2 squared is c. And so you want to write that and the resulting binomial square, you want to get in the habit of that. So again, we write c is equal to b over 2 squared. In this problem, b is 5. So when you substitute it in, you cannot divide 2 equally into 5. So you're going to have a fractional value for c. And so you square the numerator 5, you square the denominator 2. 5 squared is 25, 2 squared is 4. And the answer is 25 over 4. Is the value c. So in that problem, we have a fractional value. So let's do number 8. Bigger b value there. We have x squared minus 70x plus c. Again, we write our general formula as we've been doing in every problem. And the resulting binomial square, x over b over 2 squared. b in this problem is what? Yes, you're correct. Is negative 70. So we're going to substitute negative 70 for b. We will have negative 70 over 2. And negative 70 divided by 2 is negative 35. And then we will square that to get the value of c. And so c is going to equal, get your calculators out and plug that in, or you can write it out. You will get 1,225 as a value c. So we're done with that. So now we do one more here. We got x squared minus 11x plus c. It's a very important process that you find c because without that, you can't solve that binomial square complete the square wheel. So it's a very important process to find c. So that's why we're going to continually go over it. So in this problem, c is equal to negative 11. We substitute negative 11 in the form of b over 2 squared. Again, negative 11 over 2 cannot be simplified, so we square the numerator and denominator, and we'll have a fractional value for c, which is basically 121, which is negative 11 squared, over 4, which is 2 squared. So c is 121 over 4. All right, so now we're going to do another group of problems. Now that we've learned how to solve for c, we can now solve a quadratic function by completing the square. So we're going to do a problem like that. It says solve each equation by completing the square, round to the nearest tenth if necessary. Let's see what NOLA MATHMAN does here. So we have a group of problems here that come. We expand it so everyone can see it nice and clearly. And so let's see which one. We're going to do the first one. That'll be 11. X squared plus 4x minus 12 equals 0. Now, if you saw by completing the square, you must create the third term. So you want to get rid of that constant negative 12. You add 12 to both sides. Now you have the form you want. X squared plus bx, in this case 4x. You leave a space because you know if you create the c term like we've been doing. So we add what c is equal to, which is b over 2 squared. What you do to one side, you got to do to the other side. So we add on the right side to 12, b over 2 squared. We pull out b, which is 4, and we substitute it into both sides for b. And so on the left side, we have 4 over 2 squared. And on the right side, added to 12, we have 4 over 2 squared. Now, once we do this, we can simplify. 4 over 2 is 2. 2 squared is going to give us 4. And again, you're doing the same calculations on both sides of the equal sign. So by the time you simplify, you'll be left with x squared plus 4x plus 4 is equal to 12 plus 4. Now, once we have this trinomial, we know it's going to be a perfect square. That's why in the last example, we're writing the form x plus b over 2 squared. So now we know it's a perfect square in the form of x plus 2 squared. We take the square root of both sides. That will give us plus or minus 4 because the square root of 16 is 4. And so now we have two answers which quadratic should produce. We have an equation that's x plus 2 equals 4, x plus 2 equals negative 4. We solve for x by subtracting 2 on both sides. X for the first equation is equal to 2. We subtract 2 from both sides, and x will equal negative 6 in the second equation. And so our values are negative 6 and 2 for x. And so we've now solved by completing the square. So now we're going to do number 14. In number 14, we already have it in the form of x squared plus bx. We only have two terms on the left side like we like. So we add the b over 2 on the left side of the equal sign, which means we must add b over 2 squared to the 15 on the right side, which we did. We pull out our b value, which is negative 2. We substitute into b on both sides of the equation, so you'll have negative 2 over 2 squared, and you'll have 15 plus negative 2 over 2 squared. Using the order of operation, we will divide. Negative 2 divided by 2, which is going to give us negative 1. So we've got x squared minus 2x plus negative 1 squared equals 15 plus negative 1 squared. We square the negative 1, we'll end up with x squared minus 2x plus 1, and we'll have 15 plus 1. So now we write the binomial square that is equal to, which is x minus 1 squared is equal to 16. We will now take the square root of both sides because that's the inverse of square. We get x minus 1 equal to plus or minus 4, which is the square root of 16. So now we have two equations that are formed. X minus 1 equals 4. X minus 1 equals negative 4. We add 1 on both sides. In the first equation, x is equal to 5. We add 1 on both sides to the second equation, and x is equal to negative 3. And so our values will be 5, negative 3. Typically, we put negative 3 first, but it doesn't matter. So now let's do another group of problems here. We want to solve by completing the square. Now, you don't always get integer values. We might come up against an example where you have a rational root or you have decimal answers, so we'll see. So the next problem we have is x squared minus 14x plus 30 equals 6. We have to get rid of the constants by subtracting 30 on both sides. So we can have x squared minus 14x by itself, so we can complete the square and create the third term. What is the formula for that? We should know by now. You're right, it's b over 2 squared. So we're going to add that on the left. We're going to add that on the right next to negative 24. We're going to add b over 2. We pull out b is equal to negative 14. We'll substitute negative 14 into both sides of the equal sign. So we'll have negative 14 over 2 squared on the left, and added to negative 24, we'll have negative 14 over 2 squared on the right side equals sign. What you do to one side of the equation, you must do to the other. And since you're creating a new term on the left, you have to account for that on the right. So that's what we're doing. So once we simplify, we will have negative 7 squared on both sides equal sign. When we square negative 7, we'll get 49. So we'll have x squared minus 14x plus 49 equals negative 24 plus 49. Now we can write the binomial square, which will be x minus 7 squared, which is in the form of x plus b over 2 squared, and the negative 24 plus 49 is 25. Take the square root of both sides to get rid of the square. We have x minus 7 equals plus or minus the square root of 5, which is 5. So now we create two equations like we've been doing. X minus 7 equals 5. X minus 7 equals negative 5. We add 7 to both sides in the first equation. X is equal to 12. We add 7 to both sides in the second equation, and x will be equal to 2. And so our two answers will be x equals 2 and x equals 12. All right, now we're doing number 17. X squared minus 4x plus 1 equals 0. We have to get rid of the 1, so we subtract 1 from both sides, so we can be left with our x squared plus bx term, which is minus 4x. We will add the b over 2 squared to both sides like we normally do to complete the square. We pull out the value of b. B in this problem is equal to negative 4. So on both sides of the equal sign, we will substitute negative 4 for b. We will have x squared minus 4x plus negative 4 over 2 squared is equal to negative 1 plus negative 4 divided by 2 squared. So using order of operation, we simplify negative 4 divided by 2, which is negative 2. You'll see that on both sides of the equal sign. Then we square negative 2, and that will be equal to 4. So we'll have x squared minus 4x plus 4 equals negative 1 plus 4. Now we're able to get our binomial square, which is going to be x minus 2 squared, which is equal to 3. We have to take the square root of both sides to get rid of the square. We will be left with x minus 2 equals plus or minus square root of 3. We will add 2 to both sides. You can't simplify the square root of 3. And so as x is going to equal 2 plus or minus the square root of 3. And so we circle that answer because we cannot simplify any further. So, all right, we're done with that. So let's see what's next. We have 19 through 22. But you need to do 22 with the decimal, decimal A term. Yeah, that's what we're doing. NOLA Mathman thinks like me. So we have 0.5 x squared plus 8x equals negative 7. So again, we must have x squared, so we cannot have a coefficient in front of a. So we have to divide every term by 0.5 to get x squared by itself, because you cannot complete the square unless it's in that form. So now, as a result of dividing each term by 0.5, we have x squared plus 16x equals negative 14. So at this point, we can add b over 2 squared to both sides, which we do once we have our bx term. It'll pop up here in a sec. And so we will also add b over 2 squared to negative 14 on the right side of the equal sign. Pull out the value of b, it's 16. We substitute into b on both sides of the equal sign, and we will have 16 over 2 squared on the left, and we have negative 14 plus 16 over 2 squared on the right. 16 divided by 2 is 8. So we write that down, and that will give us 8 squared on the left side, and we will have 8 squared on the right being added to negative 14. Now we simplify 8 squared, that will give us 64. We have x squared plus 16x plus 64 equals negative 14 plus 64. We write our binomial square, which is x plus a squared, and that will equal 50. Now, in order to get rid of the square, we take the square root of both sides. That will give us x plus 8 equals plus or minus the square root of 50. Now, since 50 is not a perfect square, it has a factor that's a perfect square. We're going to break that down into 25 times 2, because we take the square root of 25, we know that's 5. So we will subtract 8 on both sides to get x, and the answer will be negative 8 plus or minus 5 times the square root of 2, because the 2 is still under the radical since it's not a perfect square. And so that will be our final answer. And we are done with this process. So we have used the concept of completing the square to solve quadratic functions. We have mastered that concept. And so until we meet again for another fun math adventure, it's the NOLA Mathman signing off. Have a blessed and prosperous day.